What if I told you electric cars were once as popular, and in some places more popular, than gasoline cars? And what if I told you they quietly helped redraw our cities and power grids long before Tesla ever showed up? Welcome to Unboxd Origins. I'm Howie, your resident science geek and accidental trivia sponge.
And I'm Wyatt. I ask the big questions. Sometimes philosophical, often skeptical, always curious.
Today, we're digging into how did electric cars influence transportation? Picture the late 19th century, streets a noisy stew of horses, steam, and early combustion experiments, but also this whisper-quiet newcomer on the block, the electric carriage. Inventors across Europe and the United States were fiddling with batteries and motors, and by the 1890s, you had real usable electric cars on city streets. They didn't need hand cranks, they were smoother than steam, and they started out as a practical urban vehicle. Names you might recognize: Gaston Plante for the rechargeable lead-acid battery, invented 1859, and in the US, folks like William Morrison tinkering with battery-powered vehicles helped make the idea tangible. By the early 1900s, electric vehicles were a visible part of the urban mix, quietly competing with steam and gasoline. Urban elites liked them for the lack of smell and noise, and there were even early electric taxicabs in cities like London and New York. At the turn of the century, electric cars had real advantages. They were easier to operate, no crank, no gear shifting as we know it, and they suited short, predictable city trips. Women drivers were often marketed to because society at the time equated no sweating, no cranking with convenience. Electric delivery vehicles and taxis worked well in tight urban grids. But then, the internal combustion engine staged a slow-motion takeover. Henry Ford's assembly line production techniques dramatically cut the price of gasoline cars. And expanding oil production and refueling infrastructure made gasoline more convenient and affordable. Batteries were heavy and held limited energy. The term range anxiety didn't exist, but the problem did. Roads improved, allowing longer journeys, and a culture of long-distance mobility formed around gas stations and road trips. By the 1920s, electric cars had largely faded from the mainstream, surviving in niches like milk floats and industrial vehicles. Fast forward mid-century, and electric cars pop up as bursts of interest, usually whenever fuel prices spike or policy nudges appear. The 1970s oil crises made engineers and policymakers peek back at electric drivetrains. But the real technical revolution came later. New battery chemistries, from nickel metal hydride (NiMH) to lithium ion, dramatically improved energy density. The 1990s gave us the Toyota Prius, the hybrid that normalized electrified propulsion, and California's zero-emission vehicle rules nudged automakers toward electric prototypes like GM's EV1. Then came the game changer for mass imagination. Tesla's Roadster and later Model S proved electric cars could be fast, desirable, and long-range. Meanwhile, policy levers, tax credits, emissions targets, city low-emission zones started pushing markets in ways that raw preference had not. Charging infrastructure grew from a trickle to a planned network, and battery prices began their steep fall as manufacturers scaled up.
Aha! Here's the twist people often miss. Electric cars didn't just replace one appliance with another on the road. They started a two-way conversation between transportation and the electrical grid. Early electric vehicles were closely tied to the spread of electricity in cities. Wealthy homeowners with access to power were the first buyers because they could recharge at home. That early demand helped normalize home electricity use. And utilities began thinking about transportation as a potential new load. Later, as EVs grew, they reshaped how utilities plan capacity and think about peak demand. We now talk about time-of-use pricing, smart charging, and vehicle-to-grid services. Those are not byproducts. They are direct consequences of treating cars as electrical devices. So the real surprise is this: electric cars have been as much about power system evolution as they have been about mobility.
Exactly. That insight cascades into nearly every modern planning discussion. When cities consider electrifying buses and taxis, they're not just buying a quieter vehicle. They're planning depot electricity, grid upgrades, and sometimes new substations. Fleets electrifying lead to concentrated charging demands that utilities and urban planners must coordinate. At the same time, electric drivetrains change the vehicle's internal economy. Fewer moving parts, different maintenance patterns, and opportunities for over-the-air software updates that alter vehicle behavior mid-life. And it's not just passenger cars, trucks, ferries, even aircraft prototypes are moving toward electrification, which means the supply chain for batteries, motors, and power electronics now matters politically and economically. There are geopolitical ripples too. Countries that scale battery manufacturing and secure mineral supply chains gain leverage, and that shifts the balance of industrial power. But there are human-scale effects as well. Electrification cuts noise in city centers, which changes how people experience streets. Quieter buses and trams make early morning deliveries less disruptive and make pedestrian areas more pleasant. Reduced tailpipe emissions have measurable impacts on public health, especially in dense neighborhoods that suffered decades of dirty air. Though the climate and air quality benefits depend on the carbon intensity of the electricity used to charge those vehicles. Electrification also intersects with new mobility models, ride-hailing fleets turning electric, micromobility like e-bikes and scooters proliferating, which changes congestion patterns, curb usage, and transit planning. And don't forget second life batteries. Retired EV packs can become community energy storage for solar systems or backup power. Folding transport's waste stream into local energy resilience solutions when economically viable.
Aha! Yes, I really will say it twice. Another overlooked contradiction. We often talk about electric cars as the great climate solution of today, but their actual influence has been iterative and sometimes counterintuitive. For instance, early EVs were urban machines that implicitly encouraged denser city patterns because they weren't suited to long rural runs. Then, as range extended, they enabled suburban and long-distance travel, much like gasoline cars did. So electrification can both support compact urban forms and enable sprawl depending on the context. Also, the social implications are complex. Electrification could democratize mobility. Cheaper operating costs mean lower total cost of ownership. But if policies favor expensive EV models first, you can get a two-tiered mobility system where affluent folks enjoy the cleanest options and poorer communities bear the brunt of legacy pollution. So electric cars influence transportation not only technically by swapping engines, but socio-economically and spatially by influencing who moves where, who breathes clean air, and who has reliable access to charging.
Those contradictions are why policy and planning matter so much. The technical journey from lead-acid to lithium-ion and the cost curve for battery packs is a necessary condition for mass adoption, but not sufficient. Charging networks need geographic coverage and reliability. Urban planners must redesign curbs and parking rules for charging and shared fleets. And regulators need to think about recycling and supply chains so that the environmental benefits aren't undermined. We've seen positive feedback loops already. As cities electrify buses and municipal fleets, local air improves, public support rises, and private adoption becomes easier. We've also seen the rise of smart charging algorithms that shift large loads to times when renewables are abundant, turning a potential grid headache into a renewable integration asset. Then there's the future stitch. Imagine autonomous electric fleets, vehicles that drive, charge, and dispatch without human drivers. That scenario rewrites ownership models, reduces parking demand, and could make roads more efficient if managed correctly. If that future combines with vehicle-to-grid functionality, fleets could become mobile batteries that help stabilize the grid, On the manufacturing side, the shift to electric drivetrains requires retraining workforces and reinventing assembly lines. It creates new jobs in software, battery chemistry, and power electronics, while diminishing the demand for some traditional mechanical roles. So electric cars influence transportation across the entire life cycle, from the minerals dug out of the ground to how people plan their commutes and design cities.
To put it succinctly, electric cars changed not just the hardware of transport, but the relationships underlying mobility between drivers and cities, between vehicles and the grid, between markets and regulators. They introduced an interplay between energy policy and transportation policy that was mostly absent when oil did all the heavy lifting. And there's one more neat historical twist. Early electric taxis in cities helped prompt municipalities to consider curb regulations and vehicle licensing in new ways, which later fed into how gasoline taxis were regulated too. So the legal and institutional architecture that governs modern transport owes part of its shape to the electric vehicle experiments of a century ago.
Which brings us to the why it matters. When people ask, are electric cars the future? The right answer is both yes and it depends. Yes, because the technology allows us to imagine low-emission, quieter, and potentially cheaper mobility. It depends, because realizing that future requires decisions. Where charging infrastructure goes, how we recycle batteries, who gets access to clean vehicles, and how we balance trade-offs like mining impacts versus pollution reduction. Electric cars don't exist in a vacuum. They've always affected grids, urban form, labor markets, and geopolitics, and they will continue to do so. Understanding that broad influence helps us make better policies and smarter design choices.
So the takeaway. Electric cars influenced transportation by being more than a different kind of engine. They were agents of systemic change. Wires and wheels tied together. They nudged utilities to rethink demand, pushed cities to rethink streets, influenced global industrial strategies, and gave rise to new mobility models. The quick, quiet vehicles of the past taught cities how to host electrified mobility. And today's electric fleets are teaching grids how to be more flexible. That's a long, circuitous influence that spans more than just replacing one fuel with another.
If you care about air quality, urban livability, climate goals, or even how your electricity bill will behave in future, electric cars matter. They are simultaneously transportation devices and energy assets, and that dual nature is what gives them outsized influence. We're not just swapping motors, we're rewriting interfaces between cars and power, between streets and people, and between markets and policymakers. That's why the history matters. It shows us patterns to copy and mistakes to avoid. If you enjoyed this unpacking of electric cars and their ripple effects, please like, subscribe, and share this episode. How did electric cars influence transportation? By quietly and persistently rewiring it from our streets to our sockets.